Hey calculus kids, this is Dr. Callahan with Week 9 Monday. How are you guys doing? I hope you had a wonderful week. Keep in mind your warm-up log is going to be due on Week 9 Friday, so it's actually going to be this Friday. And everything is going to be for 300 points, 100 for the warm-up log, 100 for participation, 100 points for preparation. And just make sure you guys have all the boxes completed, especially on the hybrid days. If you're not sure about what the warm-up is, just take a look at which box is missing, which week and day it is. Go onto your MS team and just watch the beginning of those videos for the lessons, and you'll be able to see the warm-up. Okay, so let's go ahead and create your assignment for Week 9 Monday. AP Calculus AB, Semester 2. And today we're going to talk about slope fields and equations. Make sure you guys watch the video in its entirety, and if you're doing this at home, make sure you upload it to the MS team assignment. You need to check in with me before the end of the period, which is at 9:41 a.m., so that way I don't mark you absent. And your assignment is going to be due by 3 p.m. today. And let's go ahead and sign that. All right, let's go back and get started with today's stuff. Here is the breakdown of what we're going to be doing. I'm going to have you guys do a quiz if you're doing this at school. However, if you are at home, I'm going to go ahead and modify this a little bit so that way you can still work on this at home, but you'll have a little bit of extra time. Let's go ahead and assign. And so if you're doing this at home, make sure you insert this information on your laptop for the joinmyquiz.com. So yours will just be a little bit different. So I'm going to put or at home, click here. Come on. And by click here, I mean just type in the joinmyquiz.com and then insert the code right there. All right, let's go ahead and take a look at your guided notes for today. So your guided notes starts over here with, and there's several pages, 1, 2, 3, 4, 5, 6, 7 pages. So here are the first ones. Page 1, page 2. Page 3 tells you a little bit more about slope fields, specifically what it is and how you go about calculating them. Page 5 is where your example starts today, and I also included the steps for you. Page 6 is right here. 7 are some additional examples. They're a little bit more difficult, and I actually included the steps for you guys as well. And then page 8. Eventually, we're going to start with differential equations and Euler's method. So that's kind of what we're going to go towards after this. Okay, so with that said, let's go ahead and get started. Oh, you know what? I just noticed that this totally did not transfer over adequately when I was explaining it. But anyways, page 1, page 2, page 3, page 4 is where your note starts. Page 5 is continuation of your notes. Page 6 and 7 goes over the steps of additional examples. And then page 8, if you need some additional more assistance on slope fields, make sure you guys type this in to watch the video. And so with that said, let's go ahead and get started on this page here. First thing I have you guys do is make sure you read the steps. Okay, so let's take a look at example 1. With example 1, your dy over dx is the equation here, and it says sketch a slope field for the given differential equation at the indicated 8 points. Okay, so let's take a look at the first one here. So let's start off with this point right here. At this point, your x value is at a positive 1, and your y value is at a negative 1. Now with this, what you're going to do is you're going to simply plug in the x and the y into this equation. So you have just 1 minus 2 times negative 1, so a plus 2, which is going to be 3. So what that means is this is your slope. So at this point here, it is going to be a slope of 3 over 1. So it's going to be like up 3 over 1. And if you can draw it, it's kind of a steep slope looking like that. Taking a look at the next point right here, this point is at 1, 0. So if I plug this in, then I will have a 1 minus 0 is a 1. So it is at a slope of 1. So it's a little bit less steep. Next point right here is going to be at 1, 1. So 1 minus 2 is a negative 1. So with this one, you're going to have a negative 1 slope. Next point you have is at a 1, 2. So you're going to have a 1 minus 4. So that's a negative 3. So something like that. Let's continue on with the next part. Here you have a negative 1, which means you have a negative 1 plus 2. So that's a positive 1. So this will just have a positive 1 slope. Next one here is going to be a negative 1, 0. So you have a negative 1 plus 0. So that's a negative 1. Next point is going to be a 1 or negative 1, 1. So you have a negative 1 minus 2. So a negative 3. Okay, and the next one here is going to give you a negative 1, positive 2. So that's going to be a negative 1 minus 4, negative 3. Oh, you know what? I made a typo here. Hold on a second. This one should be a negative 1. Negative 1. Yeah, it should be a negative 1. So this should be less steep. Sorry about that. Like that. There we go. And then the next one should be a negative 3. There we go. So generally, that's what you're going to be doing with your slope field. So I'm going to have you guys try this one on your own. So go ahead and pause the video and give that a try. All right, take a look at your answers right here for example 2 or example 1B. All right, let's go ahead and take a look at the following examples here. So pause the video and see if you can determine which one of these graphs matches the following differential equations. First one is x minus 1, second one is x times y, third one is x divided by y, fourth one is y divided by x. So pause the video and create your charts and see if you're able to match them. And here are your answers. All right, let's go ahead and take a look over here. It says determine the differential equation being graphed by each of the slope field below, then sketch a solution that passes through the indicated points. Okay, I'm going to go ahead and take a look at B right here. So looking at this one here, you have your dy over dx is equal to 3x squared. Well, if I want to find my equation, which is just y, how do I get rid of a di over dx? You will have to integrate it. Integral of this is just going to be 2 plus 1, which is a 3, divided by 3. So y is equal to x cubed plus c. So if you look at this right here, if I were to go ahead and graph this, x cubed will look something like this. And that is my graph. Now let's try the third one with d. So you have your dy over dx equals y over x. To get to the y, you will have to integrate both sides. And before you integrate this, notice how you have the dy over dx on separate sides. You want to have the y's on one side and the x's on another side. So if I were to go ahead and rewrite this, I will have a dy over y equal the same thing as dx when you multiply it over x. Derivative, or excuse me, the integral of dy over y, in this situation, what you're going to do is another way of thinking about this is just think about it as integral of 1 over y dy, integral of 1 over x dx. Now, you know the integral of 1 over y is like the same thing as 1 over x, which is ln x, or ln u. So in this case, it'll be ln y equals ln x plus c. To get rid of the ln, you would just need to put an e on both sides. That cancels. Y is equal to x plus c. So looking at this part right here, it's just going to be a straight line. Slope of 1 over 1. Okay, so I'm going to have you guys go ahead and practice with this one. Sketch a slope field for the following differential equation, then find the general solution analytically. And take a look at your answers. So now that you have went ahead and did the slope fields for this, I'm going to show you guys the way that you can actually find the equation for the graph by using integrals. So looking at this right here, first step you want to do is you want to go ahead and separate the y's and the dy's together. So if I multiply y on both sides of y times dy equals negative x times dx. Once you have that, we're going to go ahead and integrate both sides. Integral of y is just a 1 plus 1, which is a 2 divided by 2. So y squared over 2 equals, same thing with the x's, negative x squared over 2 plus c. Now, if you want to get rid of the 2 in the denominator, let's go ahead and multiply that 2 on both sides. So y squared equals 2, or it'll be actually negative x squared over 2 plus 2c. The 2 will cancel, and then to get rid of the square, I will square root it. So y is equal to a plus or minus square root of negative x squared plus c. If you think about it, what is the graph of a square root? It's generally in the shape, and this going back to algebra 2, like this or like that. If you look at this part right here, it does kind of follow along that pattern. All right, so let's do a little bit more practice. So I'm going to have you guys go ahead and graph all of these by hand. So start your slope field, and next I will show you the integrated method of finding the equation of the slope fields. Okay, so pause the video and pick any 3 of your choice and give that a try. All right, let's go and take a look at number 1. I'm going to go ahead and cut this one out so that it's a little bit easier for us to see. Okay, so at this point, you should be almost done with number one in terms of drawing the slope fields. So let's go ahead and take a look at this then. Here are the slope fields for all 6 of them. Specifically for number one, this is what it should look like. Now that you went ahead and did the slope fields, I mean, it's a little bit time intensive because it does require you to use not so much a lot of work. It's just, a lot of algebra, but it's not very technical. So then looking at this, let's go ahead and find the graph instead of drawing the slope field of using integrals. So let's go ahead and separate everything first. So we're going to go ahead and divide by 4 minus y on both sides. So I have a dy. Oh, goodness. Okay. A dy divided by 4 minus y equals multiply by dx on both sides. You get a dx isolated by itself. Now let's go ahead and integrate this. So as I'm looking at the left side, it looks like it's going to be like a u substitution. So let u be the denominator, 4 minus y. Then your du equals a negative y dy. dy equals a du over negative 1. So let's go ahead and rewrite this. Change the dy to a negative du divided by u, which is the same thing as a negative 1 integral 1 over u du. If you look at this, doesn't that remind you of ln u? So that's just going to be a negative ln u, which is 4 minus y, equals integral of 1 dx is just x plus c. Now, if I want to get rid of the negative, I could do a ln 4 minus y equals a negative x minus c. Insert the e on both sides, ln cancels, and then I am left with a 4 minus y equals e to the negative x minus c. Now, what you can do in this situation is you can go ahead and take the minus c and bring it in front of the e. So 4 minus y equals c e to the negative x. Get rid of the 4, negative y equals c e to the negative x minus 4. Change the y to a positive y, negative c e to the negative x plus 4. And if you think about what does a negative e to the negative x looks like, if you're to graph it on your calculator, plus 4, 1, 2, 3, 4. So you have a line going through here, an asymptote. And then your graph looks something like this, which is similar to what this one looks like. All right, let's go ahead and have you guys do number 5. So give number 5 a try. And notice here with number 5, they actually give you a point, whereas with 1, 2, and 3, they did not do that for you. So give number 5 a try. Pause the video. Okay, so your number 5 should look something like this. And I'm going to go ahead and show you guys how to find the equation that's affiliated with this one. Okay, so let's take a look at number 5. Okay, so for number 5, you have, well, this has an x times y, but you can still divide it by the y. So you have a dy over y is equal to multiply by the dx on both sides, dx times x over 8. Or if you want to rewrite it, dy over y equals 1 over 8 x dx. Now let's go ahead and integrate both sides. Now the integral of 1 over y is just a ln y. On the right side, you're going to do a 1 plus 1, which is a 2. Divided by 2 is 1 over 16 x squared plus c. To get rid of the ln, you're going to insert e on both sides. So y equals e to the x squared over 16 plus c. Now this c, you can actually bring it down to the e. So y is your ce to the x squared over 16. And if you go ahead and graph this on your calculator, what shape do you see here? It's kind of like a negative x squared parabola. And if you look at this, it is similar to that. All right, you guys. So at this point, what I would like you guys to do is you go ahead and give 1, 3, 4, and 6 a try. And then when you're ready, your answers for this, I'm going to show you guys the work for the next 2 pages. 1, 2, 3. Pause the video. 4, 5, and 6. And don't forget your quiz is. If you have some additional time, I would like you guys to go ahead and read the last 2 pages, which gives you some additional examples. And as always, I'll see you guys next time. Be safe and be kind to one another. Take care.